chain rule and quotient rule. The chain rule that we will be using in this video is f prime g minus fg prime divided by g squared. I know most of the textbook, they go by gf prime minus fg prime divided by 2. So let's take a look at the first problem. The first problem, we have square root 4x to the 5th minus 3 divided by e to the 2x plus x to the negative 6. Raise the whole thing to the 1/2 power. So we have f prime of x. Bring the 1/2 down, and then 1/2 minus 1 is negative 1/2, and then we take the derivative of the fraction inside the parentheses. So the fraction is 4x to the 5th minus 3 divided by e to the 2x plus x to the negative 6, and then we take the derivative of that. So that is a 4x to the 5th minus 3 e to the 2x plus x to the negative 6. All right, so next line, f prime of x. So we copy the front, we copy the 1/2 one more time, and then 4x to the 5th. Let's make that look like x minus 3 divided by e to the 2x plus x to the negative 6, and then to the negative 1/2, and then the derivative of that, I immediately square the denominator. So let me immediately square the denominator. That is e to the 2x plus x to the negative 6, and then the derivative of the top, that is a 20. X to the 4th power, the derivative of 3 is equals to 0. And then we copy the denominator, e to the 2x plus x to the negative 6, and then minus for the quotient rule, and then we copy the numerator, 4x to the 5th minus 3, the derivative of the denominator, that is e to the 2x times 2. So this 2 is by chain rule. And then the negative 6, so bring the negative 6 down, x to the negative 7. So this is the answer to the first function. And then the second function, we have a g of x. We have g of x equals to the whole thing raised to the pi, right? So we have a big fraction raised to a pi, e to the ax plus e to the 3rd, which is a constant, divided by c to the x squared plus 10 to the 10x, not 10 to the x, 10x. And then the derivative of that, so we have g prime of x. We bring the pi down, and then the pi minus 1. And then by chain rule, we multiply the derivative of the fraction. The fraction is e to the ax plus e to the 3rd, c to the x squared plus 10x. And then this one, same thing, e to the ax plus constant, cx squared plus 10x. All right, so let's take the derivative of the fraction using a quotient rule. So g prime, we copy this one more time, so I'm going to just copy it. So copy and paste that right over here. And then we draw a long fraction bar for the chain rule. Cx squared plus 10x, and then square. The derivative of the numerator, that is e to the ax. The derivative of ax is equals to a, and then e to the 3rd is equals to 0. Copy the denominator, cx squared plus 10x minus the numerator, e to the ax plus e to the 3rd, and then c to the x squared, c to the x squared. Okay, so that one, c to the anything is c to the anything, right? So c to the x squared, and then you have a ln(c). But since there is an x squared, you need to take the derivative of that, which is 2x, and then plus what? Plus the derivative of 10x is 10. All right, so that's the answer to the second function. And then the third function, we have a function z. So let's write this down. We have a function z equals to t to the 3rd power divided by a square root, 2t to the 4 plus 1. All right, so we have z prime. So we have z prime equals to, we have to square the denominator, right? So we have a square root 2 to the 4 plus 1, and then once we square that, the square root is gone. The top, we have a 3t squared times the square root 2t to the 4 plus 1, and then we have to do a minus t to the third, and then we multiply. We bring the square root down, and then square root minus 1 is negative 1/2. So t to the 4 plus 1 plus t to the 4th power plus 1. And then we multiply the derivative of the radicand, that is equals to 8t to the third plus 0. Can we clean that up? Yes, we can. So the z prime is equals to 3t square root 2t to the 4 plus 1, and then the denominator is just the radicand, 2t to the 4 plus 1, and then minus 8 divided by 2 is 4t to the third times itself, 3 plus 3 is 6 power, and then what else? And then we have the negative 1/2 power. So 2t to the 4 plus 1, and then raised to the negative 1/2 power. Alright, so that is the end of the third function. And then the last function, as you can see, I have 3 square root, one inside of the other. This is not really a quotient rule, but this problem is worth a discussion. You might get that on a test. Who knows? Okay, let's change to a different color. So write down the problem first. We have y equals to, we have a big square root, 2x, and then plus another square root, 3x, plus another square root, 4x, right? So first of all, we start from the outer layer. So the bigger square root. So that one, we bring that to the bottom, and then we have a negative 1/2, and then we copy everything inside. So 2x plus the square root of 3x plus the square root of 4x. This one, I don't recommend you to change the square root to 1/2 power. The answer is cleaner, much easier to read if we go like this. And then this one, you take the derivative of the inside, right? I do not recommend you to write the ddx anymore. This one, you should just keep going. Just keep using the chain rule over and over again until you reach to the innermost layer. I don't recommend going by the ddx. No, that one not recommended. I will just take the derivative. I will just do a chain rule like this, and then just go straight to the derivative. Okay, the derivative of 2x is equals to 2, right? And then plus that one, we reach to the second square root. So that is 1/2 3x plus the square root of 4x, and then raised to negative 1/2. The derivative is done. The derivative of this piece is done. And then we have to multiply the derivative of the inside, 3x plus 4 root 4x. So that one, that brings us to another chain rule. Do we have enough space? Like right here. So that one is another chain rule. So that is 3 plus 1/2 4x raised to negative 1/2, and then we have another chain rule. So multiply 4. Yep, I will just do it like that. So let's check this one more time. We have square root, another square root. So we bring the bigger square root down and then raise to a negative 1/2, and then we take the derivative of this radicand. The derivative is 2 plus you bring the 1/2 down, 1/2 minus 1. There is another layer, so that layer is 3 plus 1/2. Bring the 1/2 down and then negative 1/2, and then the radicand 4x, you take the derivative of that, that is equals to 4. Alright, so that is the end of this video. If you think this is helpful, you really like it, you want to see more kinds of video like this, give me a like, share the video for me, click the subscribe button. If you're on your way out, I appreciate your help and support. I will see you all in the next lesson. Signing out.